Okay, so I want to look at another topic, which is bearing. Before we solve this example, I'm going to be, telling you some things that you need to know. Bearing is very straightforward. Once you, uh, see what I want to do now. So I'm going to explain numbers of things so to make you to anytime you see a bearing question, you'll be able to solve it. So the first thing I'm going to look at is how to manipulate yourself on the bearing so that you'll be able to know the angle to be used. Now we have from 4 cardinal points, you have this. You must be able to know how to manipulate this 4 quadrant. You must be, once you are able to manipulate this quadrant, then the remaining ones are simple in bearing. So, and here is north. You indicate this place. All the angle start from north. So it is from 0, this is 90, moves clockwise, this is 180, this is 270. At any point you draw it, then 360. So, which means if I'm to draw any angle in bearing, I have to start from north. Be it 0, be it 1, be it 100, be it until 360. I have to start from what? From 0. So, and each quadrant has 90 degrees. So you must know that each quadrant has 90 degrees. That makes it 360. So that is first thing. Now, if I'm to draw something like this, let's say this is my north, and I have something of this nature. So when I stop, you see now I draw my 4 cardinal points. So at every point you stop, you draw this. So it will help you how to manipulate your angle for you to bring out the angle you need to use. Now, let's assume that I have an angle of x degree. So once you have an angle of x degree and you drew your line and you stop at a point, so it's equal to this place. So that is why manipulating this quadrant is the most important thing that you need to know. Because if you don't know the angle you are to use, by the time you complete the triangle, then that will make the question not to be correct. So if you draw initial 4 cardinal points and you were told that you move from that point and you stop at a point and you draw your 4 cardinal points, then you are having something like this. So you say this angle is equal to this angle. You call it an alternate angle. So let's assume from here now you move. So you now join this place. You see now, here now still draw your 4 cardinal points. So how do you now get this angle here? Probably you want to get this angle now. You said 90 minus x. So that is why I said you must know how to manipulate yourself in all these things. Once you are able to manipulate yourself, then you are good to go. So now, if I need everything, for instance, I need everything. I'm able to calculate here to here. So I now need this place. Probably I was given an angle that moves from here. Let's say an angle moves from here to this kind of place. Let's say it's 300. So in 300, you now be wondering that how will I now complete this angle? But they will have supplied the distance here, the distance here, but you need this particular angle to even solve anything on this diagram. So how do you now do it? Since you already been given the bearing from, I told you that all bearings start from north, which is 0 degrees, and it moves clockwise. So which means you already know that at this point is 270. Don't forget this one is 90, this is 180. So if it at this point is 270, so I can calculate this place, which means I will subtract 270 from 300. That gives me 30 degrees, which means this angle here is 30 degrees. So now, by what I have said earlier, that look at this, this is a 4 cardinal point, and a line is drew from here to here. So which means this angle here is alternate to this angle. Here is 30. You see how I get, so all the angle here now will now be 90 minus s, then plus what? 30. So this is how you'll be manipulating a triangle. So once you are able to manipulate all these cardinal points, that you know that if a line is drawn and you have another cardinal point, then the first angle is equal to this, as in when they are alternate to each other, they are equal. So that is how will be manipulating it. So I will still come and explain more of it now. By the time we solve question, you see that bearing is very simple. Once you are able to manipulate the cardinal point. Now I want to explain the three formulas that we need in solving bearing. So the first one I'm going to talk about is the Pythagoras theorem. If at the end of the day, by the time you finish the question and you are able to come up with a triangle and you form a right angle triangle, having, let's say, A, B, C. Because this angle is facing this side, you write small here. Then this angle is facing this side, you write small b here. This angle is facing this side, we write small c here. So what is the Pythagoras theorem is saying? I believe you all know that is that the longest side, which is the square of the longest side, which is the hypotenuse, is equal to the summation of the square of the two other the remaining side. So what am I saying? I'm saying b square equals to a square plus c square. So this is what Pythagoras theorem is saying. So which means whichever, if you are giving A and you are giving B and you are asked to calculate C, then you can now make C the subject of formula, then you get your. So at the end of the day, I have C square equals to B square minus A square. So maybe probably if we are giving C and I am giving B and you need A, then A will become A square equals to B square minus C square. So this is how you play around with this first formula. So this one of the formula you need in answering bearing question. So we are having. So that's why I'm just saying that at the end of the day, if you draw you interpret the question, and at the end of the day you have a right angle triangle, then what you can apply is right angle triangle. Then if the now requires you to find any angle within the right angle triangle, then you can now use your SOHCAHTOA to now form whatever you want to form. So let's assume I want to find, I have one of the angle, maybe I have angle A, I need either B or either C, provided that I have one side of it. If I have one angle, then I can calculate anything. So if I have, let's say we are having the angle here, this angle A now. So I need to calculate, I have B and I need to calculate C. So I will just say adjacent hypotenuse. And from the SOHCAHTOA, then we now look at it. Which one gives you what you read here? Like adjacent hypotenuse. So adjacent hypotenuse, that is cos. Now say cos A is equal to, which one is adjacent? You mentioned C over hypotenuse B. From here you can now calculate the angle of A. You can calculate angle A here. So that is the first thing. The first formula is the Pythagoras theorem in answering bearing question. So another one I'm going to talk about is the cosine rule. Cosine rule. Cosine rule. So cosine rule. What is the cosine rule saying? So the cosine rule is saying that if I have two sides A, B, C, let's say I have side C and I also have side B. C is facing here, B is facing here. So I now need this guy here. So I already been given angle A. So that is how you can calculate use cosine rule. So you can use cosine rule if you have two sides with one included angle. So what does the cosine rule say? Cosine rule say that if I am to calculate the smallest, this side A now, that is unknown, by knowing the C side and B side. They say that the square of C, that is small c, then it will be equal to the square, the addition of the two other side in square. That is, I'm having, okay, sorry, I'm looking for is A that is on me now. So it becomes A square equals to the other two sides, B square plus C square, then minus the product, the 2 times the product of the two known side. That is 2 times, let me just put it together, 2 times BC. Are you getting it? I don't need to cram it. Just follow what you are having. Then, because I'm looking for this, so it won't be part of the addition in square here. Then minus the product of the two. Then cos the angle of what you are looking for. That is A. So you now imagine, let's assume that I know all the 3 sides and I need to calculate the angle, maybe one of the angle, by knowing all the 3 sides. So I can also use this formula. I'll substitute what A is, substitute what B is, substitute what C is. Then I now make cos A the subject of formula. I already got in there. From there I get what angle A is. Now another thing that will, from here now, you can now begin to manipulate yourself. Let's assume I want to calculate B now. B square, it will give me what? A square plus C square minus 2AC cos what? This is what I'm looking for, cos B. That is angle B. That is angle B. Do you see now? So which means the same thing. If I'm looking for C square, that is this small side, then by knowing 2 other sides, which means I've already known the angle here, it becomes A square plus B square minus 2AB minus 2AB, that is the product of the two, cos what I'm looking for, which is this C, capital C, so which is the angle. So this is the cosine rule that we are talking of. So from here, this is the second formula. So you don't need to cram it. The side you are, square of the side you are looking for equals to all this. So you have everything that is there. So that is the first thing. So the second formula that we are going to look at is this. Second formula that we are going to look at is this. Is sine rule. Sine rule. If you look at Pythagoras, if you look at the cosine rule, and if you want to look at sine rule, it's like if you, at the end of the day, by the time you interpret the equation and you now have a triangle, that you already have the two of the angle of the 3 angles, that is A, B, C. Let's assume you already know this angle A, you already know angle B, and you are looking for angle C. You see now, by just knowing one side of it, let's say you know this one. So where we can use this one is that you know 2 angles and one side is not known, then you can use it. Even sometimes you can know 2 angles, then if you know 1 angle, then with 2 other sides, then you can still apply sine rule. So it just depends on the one you have the parameter for it. So now if I know 2 angles and so what the formula is saying is that sine A over small a is the same thing as sine B over small b is the same thing as sine C over small c. So by the time you now substitute whatever in this triangle into this equation, the complete one with 1/2 complete, that is what we will use. What do I mean? If I already know sine A, I know B, then I don't know sine B and I don't know sine B and I don't know small b, but I know sine C and I don't know sine C, which means it's the C I'm looking for. I can now put the 2 together. Not that you solve the 3 at once, you relate them together, the one complete one and the other one half complete. So you have sine A over small a equals to sine C over small c. So I'll substitute the value of C, A, substitute the value of small a, substitute the value of capital C, that is the angle. Then I will now from here, I will now look for C. Here now it will just be C equals to A sine C over sine A. So from here I'll be able to calculate my C. So these are the three formula I'm going to be playing with in answering bearing question. So if you see bearing question, just know that is a bonus mark. It's a bonus mark. You won't be using more than those three formula I just mentioned now. So let's now answer question number 1 with what I've explained. But by the time I'm solving it, I will still be explaining so that you'll be able to get it more. Now the first question is this. It said that triangle PQR is right angled at Q. Right angle at Q. PQ equals to 3a centimeter there, and QR equals to 4a centimeter. Determine line PR in terms of it. That is first question. So the question says a triangle PQR which is right angle at Q. So they are saying the right angle is at Q. So that is what it means. So PQR with what? With PQ to be 3 centimeter. PQ here is 3a centimeter. And QR 4 centimeter. QR 4 centimeter. That is 4a centimeter. 4a centimeter. So the answer we should find 5p. We should find this place. We should find this place. This line, this is what we call line PR. Or we can also say it's the same thing as Q is facing small this place, small q. So we are finding line PR. So using this right angle triangle, two sides are known. Then what do we use? We use Pythagoras theorem. So for me to now calculate, because I'm finding the longest side, I will add the remaining two other sides. But if you are finding one of the shortest side, then you now subtract the remaining shortest side then from the longest side in square. So what do I mean? So finding line PR will just be equal to line PQ. That is, this one becomes square plus line QR square. So I'll substitute their value. PQ is 3a all square, then plus QR is 4a all square. So I'll be having equals to 9a square. That is 9 times 9, 8 times 8. 9a square plus 4 times 4, 16. 8 times 8, a square. So this one will become 25, 20. That is line PR all square equals to 25a square. So finding the square of both sides, we find the square of both sides. That is finding the square root of both sides. We have PR, line PR equals to square root of 25a square. So that will give square root of 5 is 5. Then square root of a square is 8. So this is the answer. So this place is 5a centimeter. So don't forget the unit, centimeter. So we should find PR in terms of what? In terms of it. So that is that. I just brought this one so that you're able to apply the Pythagoras theorem. So you see all this one most a lot in objective question. So you'll be given something like this, at least you'll be able to find yourself out from there. Now the first question that says something on the bearing is this. Say the bolu travels distance of 24 kilometers from S and on a bearing of 60 degrees to Y. So let's interpret. So the bolu started from a point. So that is what you need to know. And let me clarify something. If you are so this is where most of the people make mistake in when they are answering questions on bearing. Whenever you see, let's say P from Q, the word is P is leaving Q. So your starting point is Q. Are you getting now? P from Q. So your starting point is Q. So whatever is now the bearing or distance that P leave Q with, you now start to draw it. So once they measure a position from let's say an element or a parameter from a parameter, so the from the parameter is the starting point. So that is that. So I'll just keep that one in mind. So let's now answer the first sentence. That means the bolu travels a distance of 24 kilometers from X on what? On a bearing of T 60 degree to C. So this is where the bolu start from now. So this is the bolu. I told you this is not which is what? On 0 degree. You don't know that one within you. Everything you have to start from 0 degree. And the bearing is 60 degree. So this is X. Y, bolu leave Y at on the bearing of this to Y with a distance of 24 kilometers. So how do you now draw 60? You start from a 0, you just move and stop, because a quadrant is 90 degree. A quadrant is 90 degree. I mean this something like this is 90 degree. You come like this 90 degree, like this 90 degree, like this 90 degree. So of which the bearing has to start from 0, and this is the 0 point. So all your bearing has to start from this. Every angle you are giving, any angle you are giving bearing has to start from this point. So the magnitude of the angle tells you where to stop. If it's more than 90, you come to the next quadrant and stop. If it's more than 180, you come to the third quadrant and stop. If it's more than 270, you come to the fourth. You move and reach fourth quadrant and you stop. So that is very, very straightforward. So let's now interpret 60 degree. So which means 60 degree is not up to 90. I have to stop. I will draw a line. Then I stop. Where I stop, I draw 4 cardinal points there. So I have this. You see now, don't forget this place is TS, which is starting from 0. So we have that. So here now is my 60 degree. And don't forget, the distance moved is 24 kilometers. 24 kilometers. Then that is the first statement. I've already interpreted this first line. So the second line says he then travels. So most of the people, they will think that somebody who left this place and got to a point here, which is point Y. They now said he then traveled. They didn't say that he came back to initial position and make another journey. So from that is the stopping point. He continues his journey from there. So he then travels a distance of 18 kilometers to a point Z, and Z is 30 kilometers from X. You see now, if he travels from a point, which means, look at this, the distance from here to here is just how many? It's just 24 kilometers. And now a distance, you now move from this Y, a distance of 18 kilometers. If you are to draw the distance, how will it be? Should it be longer than this one? No, you have to draw it with sense. So which means if I'm to draw, which means if you move from a particular bearing, but we are not told which bearing that it moves. So from here now it moves, and it's 30. This is what you now know, and it's 30 kilometers from C. So the distance, if you should come like this, it will not meet. You cannot get your 30 kilometers from here. Are you getting it now? So which means it will move like this. You let the distance not to be as long as this one, 18, you stop. So you draw your 4 cardinal points. So you are now told that this from here to this point now is now 30 kilometers. Was it 30? Okay, 30 kilometers. You see now? You will see that this line is longer than this line, and this line is longer than this line. So now what now remains? Here will now be Z position. So this question is a bit tricky, it's a bit somehow, but just have to apply brain. You see, that is the first line. The bolu travels on a distance of 24 kilometers from X. That is on a bearing of 60 degrees to Y. Start from X on a bearing of 60 degrees to Y. Then it stops there. He then travels a distance of 18 kilometers to a point Z, and Z is 30 kilometers from S. Z is 30 kilometers because of that distance. Which is what? Which is 18 kilometers. 18 kilometers. So it's not up to 24 kilometers. So I can't let the distance to be, so that to make it reasonable. Then and z left it has a distance of 30 kilometer from S, which is this, which means I can know this angle here. For this angle to be 90 now is what? Is 30 degree. Are you seeing now? So which means this angle here now is what? Is 60 degree. So that is all I could do in this diagram. There's no other way to bring in angle to complete. I still need this an angle here to complete everything. I still need something here to complete everything. So now let's now look at the question and see what they are asking us, so that we can know what to do. So the first question is that draw the whether they ask you to draw or not. Once you see bearing question, you have to draw. So that is, there's no dispute about that. So once whether this one just whether they ask you to draw, once you see a bearing question, you have to draw. So the first question is that draw the diagram to show the position of S, Y, Z. So S, Y, Z. So this is the diagram. So the second question, what is the bearing of Z from Y? You see now, what is the bearing of Z from what? From Y. Which means you have to calculate a bearing from this edge to this point. So that is what we need. But initially, from here to here, we already have 90. You see now, we already have 90. Once we already have 90 here, this is how you now begin. This is where the manipulation comes in. And not like manipulation, that this is where the real game. I have to open your eyes very well. So which means I need a total number from here down to this point. How will you do that? Now let me bring that part out. I have something like this. You have this part. You have this part as 60. You have a line comes like this. We don't know x. Let's say this part. Now that one, but we already know this part. You see now, which means if I know s, how will I know this place? It will be whatever I get from here. It will not be, this one will not be, because from here to here is 90. It will not be 90 minus x. So this, for the bearing now, will not be what? 90 plus what? 90 minus x. Because I need a distance, this is zero origin, that will move from here to touch this line that z left y with. So that is what they are asking us. They said, what is the bearing of z? Where is z? This is z. From what? From y. From y. This position. So we need to calculate this angle. Do you see the logic now? So I need to calculate x. How do I now calculate x? With this triangle now, I will not be able to first of all calculate the whole this angle. That means I need to calculate everything here. So once I am able to calculate everything here, I already gotten part of it, which is 60. I will subtract whatever. Let's say I add b at the end of the whole result. I will now subtract 60 from it. That will give me what s is. Once I'm able to get s, I subtract it from 90. I get what this place is. Whatever this place is, I will add it to 90. That's all. So that is why I said in bearing, you have to know how to manipulate yourself on this quadrant. Everything just on this quadrant. So I hope this, what are the analysis here now, you get it. So now, how do we now find this? So what you see our this journey now is like we're walking backward. Before find this place. Once you find here, you subtract 60. Once you subtract 60, you subtract, well, you now get this place. By the time you got this place, you now subtract it from 90, then you're able to get that value. Then you add it to this one, and we are good to go. So now, which formula are we going to apply? Now, we have all the three sides, but we don't know any angle. So Pythagoras, this one does not give us, there's no 90 in anywhere here. So Pythagoras theorem is out of it. And we don't have any of them. We don't have complete angle. This one, this angle here is not complete, this angle here is not complete, this angle here, we don't even have anything here. So sine rule is out of it. The only thing we can apply here now is to use what? Our cosine rule. And what is our cosine rule saying? So we are to apply cosine rule here now. So because I have small y, let's write the formula. It will just be small y. You know, that is what it says. Small y equals to, because I've already put here now is my small y. Here will not be small z. Y here will not be small x. So small y equals to, I want to use the symbol here to write the formula. Since I'm looking for this small, let's say I'm looking for, because I need this angle. That's why I'm looking for this place, so that from that formula I'll be able to calculate the angle in there. So I'm having y squared equals to the other two sides, z squared plus x squared minus z times x times z, then minus times z cos what? Cos capital Y. That is what I need. You see now. So once I'm able to, from here now, I know all the three sides. I know this, I know this, I know this. So the remaining one I know, but I don't know y. So from here, this formula now, I can calculate y. Then from there I calculate my the angle. So now let me make QS the subject of formula. If I'm to make this the subject of formula, so everything here, I'll bring it down here to remove this minus. Then take this one to this other side. So what am I saying is, I have 2xz, then 2xz cos y. I brought from here, I brought everything here now to this side, which is this. So what I have left in that place is equals to, what I have left here now is z squared plus x squared, right? I will now take this one to this side, become y squared. You see now. Then I will now make cos y the subject of formula. Cos y now will now be divided through by 2xz. So we have z squared plus x squared minus y squared all over 2xz. You see now, 2xz. So I can now find my cos y to be equal to, what is the value of z? Value of z, 24. So 24 squared, then plus value of x, 18. That is 18 squared, then minus value of y. So this is where y is facing, 30 squared over 2 times value of x, 18 times value of y, z, 24. So let me continue from here. So I can now say my cos y equals to, so I'm going to press all the results here, everything together. So as if you are in exam, you do it one by one. S square, write it down. 18 square, write it down. Minus, you do it one by one. But I'm going to write all the answer here now. So 24 square plus 18 square equals to minus 30 square. So that is everything in that place gives me 0 over, I won't even bother myself in dividing because it will still be 0. So let's just do it. 2 times 18 times 24. So that will give me 864. So at the end of the day, cos y equals to 0. So y will now be arc cos is 0. You see now. So because I'm transferring this one to the cos to the other side, it starts to change. So from here, just press shift cos. That is how your y will be. I'll just say shift on your calculator, press shift. Now press tab cos. Then you now press 0 on it. The number that's here equals to it. So that is 90 degrees. So 90 degrees. So which means if this place, this is a right angle triangle. You see now, because of what we got here, that is why this one resulted to right angle triangle. Everything here now is 90. So if everything here now is now 90, look at it though. So everything here is 90. So I now need x. So which means 60 plus x equals to what? 90. My x equals to, let me use another alphabet. We already have s on the board. So let's just use a here. There's no a in the board. So I'm having 60 plus a will give me, that's everything here, will give me 90. So a will become 90 minus 60. That will give us 30. So if here is 30, so if you now subtract 30 from 90, this place will also give me 60. So look at what is happening in that place. Let's bring it out. We are having this these 4 cardinal points here. So we have a line from here and we also have another line from here. So we've gotten this place as 60. We don't know this place, we call it A. So and we've calculated everything now, and that gives us 90. So since we've already know the part that is everything is 90 and this place is 60, so which means this place will become 30. So 30 plus 60 will give us 90. So now how do I now get this place? We know that from here to here is 90. So I will subtract 30 from 90. This place will give me 60. Which means from here to here is 60. And here is already 90 already. So which is from 0. So you now add 90 plus 60. So that will now give you the bearing of z from y. So you now say, since you've gotten y as 60, you now write it down that therefore the bearing of z from y will be equal to 90 plus 60. That will give you 150 degrees. So you have answered that one. So I hope you got it. If you don't get it, you continue, you watch the video over and over, and then you'll be able to, you are good to go. Calculate the bearing of x from z. Bearing of x from z. So, and I told you all bearing angle start from north, which is on the 0 degree. So if you have to calculate the bearing of x from z, bearing of x from z, so we need to calculate from here to this place. See that this one is very tricky. So what we now do, look at it, look at something. First, before you solve, you have to first of all look at the triangle that you've drawn. Once you look at it, you now say, okay, this is the question they asked me. How will I do it? You cannot just go and be solving without knowing the direction you are going to. Now they ask us to find the bearing. Look at it now. And from the question they ask from here now, we will take us to this point. So we have to find the bearing of x. Bearing of x from z. That means I are taking what is the angle that x left with z with. Now, what do I need? I need to, this is not, this is 0 point. I need to calculate all the angle from this point to this line that will link z and x. So how will I now go about it? What is everything I need? First thing first, I need to calculate everything that is in this place. You see now, be looking at it one by one. So let me bring it out. What I have is, I have this, we have this, and it moves like this. We have this, then it now moves, probably what I'm looking at, this cannot be touching it from here. You will see it will still be inside. Because you know why? This one, let me draw this place very well. Because this place is lower than this place. So this one cannot be touching it under. If you touch it on this, so since we are having something like this and it's like this, so this one will also come and touch it from here. So we'll get the answer now. So now the first thing, looking at that, I also have something like this. So now look at it too. I need everything from here, from this point. I need everything from this point to this point. So if I need everything from this point, so if I need everything from this point to this point, how do I do it? Which means I need to calculate this point. You see now, once I calculate this point, I've already know this point. So I will now also calculate this. Well, I already know this point. This point is alternate to this place. It's alternate to everything that is here. This point is alternate to this point. Don't forget I say alternate angle. Once you draw like this and you draw a line, so this angle is equal to this angle. This angle is equal to this angle. You see now? So which means this is the line that joins this part and this part. So once I know this angle, I already know everything from here. Don't forget that this line has to stop on this bearing, has to stop here. So now, here it is easier for us. We already know the angle that is there, which is 60, what we calculated earlier. So here is 60, which means from here to here is 60. Once I'm able to calculate this angle here now, I will now subtract it from 60. Will give you, let me call this place B. Will give you what is here, this B. So I will now add this B. Don't forget this is 0, this is 90, this is 180, this is 270. So this 270 here, I will now add this B to it. Will now give me the angle from this 0 point to this line. That will be the angle of which x left y with. I hope you get the analogy. Let me go again. Let me go for the last time. Let me go for the last time. So we have, I'm bringing what is here out. We have this, and we have something like this. It moves like this. We also have an angle that moves like this, which stops like this. So I want to calculate the angle that x left y with. Left z. This way is z. Okay, left z with. Here is y. And we've gotten this place the other time as 30. That was why we were able to get this place as 60. Here is 30 because we subtract, we got this place as 30 the other time from here. So that is why we now subtracted 30 from what is here, which is 60. Since we already know that what is here is 60, definitely what is in this place too, from here to this place is 60. Are you getting it? So, but now I need something, I need an angle from here to this place to calculate. That is what I need. That is the unknown. That is the bearing they are asking us for. The bearing of z of x from z. So from this point, which is 0, north is the 0 to the line that I'm looking at. So now, how will I now get this line? Is that once I'll need to now calculate. I need to now first from the triangle, I'll be able to calculate this guy. Once I know this place, then I already know this place as 60. So I will now subtract what I have here from 60. I will be able to get this place. Let's say it's B. So once I'm now able to get this place as B, I will now continue to add from the 0, which is from the North Pole. I will now add until I get to this line that links Z and X together. So I will now add B to whatever angle that is there. And don't forget that here is 0, here is 90, here is 180, and here is 270. So I will now add this B to this 270. Whatever I have will be the bearing that X left Z with. So let's now answer the question now. So, so we now have, now I need to calculate this place. Now I have all the three sides, and I will have one angle. So any one I want to use, if I should use sine rule means that I must have one angle with two included sides. So I can use sine rule, I can use cosine rule, I can also use Pythagoras theorem. Are you getting me now? So let me just see the one that we can use, because here now I'm standing as a hypotenuse, because this is the right angle triangle. So I can use Pythagoras theorem. Will I be able? No, I can't use Pythagoras theorem because I need the angle. But I can either use sine rule or cosine rule. Let me just go with cosine sine rule. So I have this. I will just say sine. Don't forget our sine rule. Sine A. So let me use this one to write it. I will say sine y over small y equals to sine x over small x equals to sine z over small z. So you see now, but what with this now, I need z, I need angle z, but I already know small z. Angle x, we don't know angle s, so but I know small z. If I should use this and this, it becomes 2 unknown, so I cannot use this. So I know angle y and I also know side y. So I can now use the complete one with, if I'm looking for the angle z x now, I can now use this completed one with the half completed. But my point now is to know angle z. So that's where I'm going to. So I will now use sine y over y will equal to sine z over z. So this is the sine rule. So what is the sine y? Sine y is what? Is 90 degree. 90 over small y is 30. I hope you are getting it because it's facing this side. Equals to sine z is unknown. Sine z is unknown. Over small z is facing this side, 24. So this time this will divide by this. So my sine z will be equal to this time this. That is 24 times sine 90 divided by 30. So I will have, let me write it here. Here now we now have sine z equals to, so let me use my calculator. So I will just press it on 24 sine 90 equals to, I have 24, which means sine 90 is 1 divided by 30. So 0.8. Sorry, let me clean my nose. 0.8. So 0.8 now. 0.8. So to find z is arc sine 0.8. You press that in your calculator. I told you how to do it. You press shift sine, then you press the number 0.8 equals to, that is 53.1. So z equals to 53.1 degree. This is the answer. So now that I've gotten the angle as z, so how do I now get this small part? Let me call this small part. Let me name this point. Let me name it as b. So which means the addition of b plus the new angle I got here will give me the summation of what is here, which is 60. I've explained earlier. So which means I will now say b plus what I got now, 53.1 equals to what? 60. So b now will now be 60 minus 53.1. That will give me around 6.9. Let me just press calculator. 60 minus 53.1. So I have 6.9 kilometer. 6.9 kilometer. So since I have, degree. 6.9 degree. So now, since I've already known this small part now, this small part are 6.9 now. So I can now add from here up to this place. So we now say the bearing of 6.9. So we now write that the bearing of x from z will now be equal to 6.9 plus 270. So that will give you 3. This is 13. 3 6 276.9. I hope you are clear. So that's how to do it. So in bearing is very straightforward, but what you just need to know, and which is simple, is to know how to manipulate the quadrant. So that is the easiest way. So I think we are done with that. So let's see number 2. So if you don't get it, you can wash over and over again. You are good to go. So the next one now is this. So the question 2. We are done. 2 men P and Q set off from a base camp R. Do you see now? Which means we are already having a point. Let me see this one. Already having a point. You have 2 men who set up from a base camp. They have 2 men. So and the base camp is we have two men P and Q set off from a base camp R. So we are having R, and we are already having here as my north, which is 0 degree. So now let's now see what happened for oil, prospecting for oil. P moves 20 kilometers on a bearing of 205. You now go 205. 205, where does it is greater than 90, is greater than 180, but it's not up to 270. So it's between 180 and 270. You start from 0, 205. 205 is greater than 90, you move on. Is greater than 180, you move on. But it's not up to 270, you stop. And it moves what? A distance of moves a distance of 20 kilometers, right? 20 kilometers. So this place is 205, right? Your angle 205 degree. So that is the first movement, and it's P. Let's see how Q moves. And Q moves 15 kilometers. You see now, the next line you are going to draw now, you have to draw it in such a way that it's not really going to be as long as this, because this one is 20 kilometers. So, and the next one now is now 15 kilometers. So your line should be shorter than this. So moves 15 kilometers on a bearing of what? 060 degree. Whether it is 60 degree is the same thing as 060 degree, or this 060 degree. Don't when you see the angle in any form, it's the same thing. Don't know you are starting from 0. So this guy, I didn't explain it earlier, can also be written in like north 60 east. You see now, which means what is this one saying? 4 cardinal points. You have north, you have east. So which means you start from north, you move towards east, and you work 60 degrees. So this one can also be written, you can also say north 60 west. North 60 west. If you are to draw it, which means you are starting from north, you are going toward west. Where is west? West is like this. And once west is like this, so which means you move from north, you move towards west, and you go like this. So that is the meaning of all this one. So maybe probably when I'm done, I will explain that part. So it will be in this form or this form. So you just have to draw your angle. There's no problem with that. So now, as I was saying, where we are giving 15 distance and a bearing of 60. So which means it moves like this. 60 is not up to let me clear this place. It's not up to, let's use another color so that 60 is not up to 90. You move, you stop, so you go. But the line should not be long as this one. I will stop. Draw 4 cardinal points. So this place is my Q now. You see now. So which is 15 kilometers. Don't forget that this one is 205 degrees. From here to here is 60 degrees. You see now. Then what you need to do is to just join it. So I will join it. So now that's all. So here will be because this angle is facing here, small p. This place is facing here, small q. This place, everything here is facing here, small r. So now let's now see what they are asking. Say calculate a distance q from p. Calculate a distance q from p. We are looking for what? Small r. So now two sides are known. We don't know any angle now. So you now have to bring it out. So let's see what is here. Let's see what is here. We are having, look at it too. Let's do the math too. We are having, let's first of all finish, let me see. Okay. See, just see the simple trick. The first one, which is this, it moves like this. 205. You see now. Now the second one moves like this. Don't forget when it reaches 205. No, so it's not up to 270. 205. It moves and stop. And the second one moves like the 60 and what and stop. Now I now need everything from here to here. When I just remove 60 from 205, which means if I remove 60 from 205, I'll get from here to here. If I add 60 to whatever I get from here, I'll get it from here to here. You see now, which means for me to know this angle, all I need to do is 205 minus 60, which is 145. 205 minus 60, which is 145. 145. You see now, you get the logic. Now look at it again. From here to here is 205, and from here to here is 60, and I need the measurement, the size from here to here. When I just remove this one from here, just clear it off, the remaining one will be for 205. Remove it from 205, it become this angle. So which means everything here now is what 145. I already know the angle. I hope you get how I did it there. So if you cannot manipulate this, I'm still saying, if you cannot manipulate this quadrant, it will be very difficult. But once you can play around with it, bearing is very simple, very very simple. As long as you can play around with the quadrant, and you'll be able to use cells when you are given a distance of 10 kilometers should not be as long as something that is above 10 kilometers, 15, 16 and above. So with that, if I should draw this one longer now, you see another diagram here. That's what we'll be looking at. So now, we have the only one we can use here now in our formula is cosine, because we have two sides, one angle. Two sides, one angle. For us to use sine rule, we need two angles include with one side. That is the only way we can use sine rule. So if you are using sine rule, I'm going to use this symbol here to write our formula. How will our formula look like? I need this small r because P, let me say, okay, P, how I change it? PQ, 2 mil, this thing leaves, camp R. Here should be R. Okay, no, this is P. Here is R. So the PQ, the left R. So P left R with 205, and this one left with 60 degrees. So let's use this the symbol here to write the formula. So I need so let's write the formula with I need this one. So small r square equals to the addition of the two other sides in square, q square plus p square minus 2qp cos capital of this r. So let's substitute. So small r now, small r square will now be equal to small q 20 square plus small p 15 square minus 2 times 20 times 15 cos 145. So r square. So in an exam, you press this one, you write it down, press this one, write it down, press the three together, all of them together, write it down. So I'm putting the two together, that will be faster. We have 20 square, which is 400 minus 15 square plus 15 square. So that gives me 625 minus 2 times 20 times 15 times cos 175 cos 145 rather. So you have this one as a minus 2. So minus 491.49. So that becomes plus 652 plus 491.49. So r will now be equal to square root of whatever I get here now. So I'll have 652. Is this, let me confirm this, 20 square plus 15 square. Oh, okay, sorry, this is 25. 625. So 625 plus 491.49. So that gives me 1116.49. So square root of answer, So I have 33. R equals to 33.4 kilometer. If you look at it and we are to, is there any condition? Okay, nearest whole number. So our answer is nearest whole number will be equals to 33. So 33 kilometer. If you look at it reasonably, you see that it's okay with your answer. From here you know whether your answer is correct. If this line is 20, this shorter line is 15, look at this longer one. Should not be below any of this number you have. So from there you will know that your answer is reasonable. So we have gotten it as 33, R as 33 kilometer. To the nearest it should be 33.4. But we have to, the question say when you are answering and looking at writing an exam, you have to look at the instruction. It's very important. Try to read everything that pertains to that question, and you'll be able to. Some question might be cheap, but if you don't adhere to the instruction, it might lead to another thing. So the what we are giving here now is to approximate to the nearest whole number, and this is it. So now let's see, is there any other question? Okay, we are done with that. You see now, this is all just only one question, but to draw the angle, that is where the problem is. It's very simple. Just manipulate your way. All your angle must start from what? From 0, which is the north. So the last one, by in 2 days time we'll be writing MC, you'll be writing Y. Then I'll just be solving some random question. But if you have any question that any area that you want me to treat, you can just post on my Instagram page or WhatsApp. I will treat the topic. So I already said my Instagram page, which is you will search Play Maths. You see it, or on YouTube page, Play Maths Quiz. Then you are good to go. Then let's now solve the final one. Then I will know that bearing is off. So that is all about bearing. Bearing is very simple and so the other one they can ask you. So I try to bring out different areas so that by the time you see it, you're able to answer the question. So the question 3 now, it says that Q moves on a bearing of 050 degree. This 050 degree, it means that this one just telling us that this bearing is starting from north, which is the 0 point. It started from north. All angle from bearing, all the angle, whether heaven, earth, anywhere, start from north is 0 to until complete 360. From P, you see now, Q from P, which means it's Q that left P now. It's not because they mentioned Q first now. Somebody will now be thinking that, okay, it's Q that left. No, you have to look at the English sometimes. So with a distance of what? Of 8 meters. So let's draw that so that we know the next thing to do. So we have this marker is rubbish. So we have this, here is my north, which is the 0 degree point. Now, and Q moves on a bearing of, so you move from 0, you stop, it's not up to 90. You draw the distance. They say the distance, when you stop, you draw your 4 cardinal points. Here is still north. Now, and it is Q that left P. Here is P, and here is what? Q. So the distance, they said Q moves on a bearing of 050 degree with a distance of 8 meters. A distance of 8 meters. A distance of 8 meters with this angle. Q left P. So that is the meaning. With a distance of, and R moves from Q now. You see now, R left Q on a bearing of 130. So you know that all your angle have to start from the origin, which is the north. So 130 is greater than 90, you continue. But it's not up to 180. I told you this is 90, this is 180. You stop between 90 and 180. And now before you now draw, now go back to the distance. How long will the distance be? whether you are going to stop halfway or you have to draw your line that is longer than 8 meters. It depends on the distance. So let's look for it. R moves from Q on a bearing of 130 with a distance of what? 30 meters. So the next line should be longer than what? Should be longer than this first line. So 30 meters should come like this. You draw your 4 cardinal points. So here now is now 13 meters. Here is 150 degrees. Are you seeing the logic now? Then we join. You see now? So here will now be our R. We've interpreted the whole English from here to here. Now let's go again. Q moves on a bearing of 050. Q moves from here on a bearing of this on a P with a distance of 8 meters, and from there R moves from Q on a bearing of 130. It moves first quadrant, second quadrant, and stop. Because it's not up to 180, you just stop anywhere and you draw. And you now look at the distance, because the next distance given is greater than the first one. Had it been we are having this as 7, 6, I have to just stop somewhere here. So which it will now, this line will now join it here. So because it is longer than the first line and distance, so I have to come down, then I stop, then you draw, you join. So let's label this our triangle. Because this space R is facing this side, this place becomes small r. Because Q is here, is facing this side, this place becomes Q. Here is a P, is facing here, this place becomes small p. You see now, that's how you now write your formula. Let's see what they ask us to calculate. Calculate correct to 3 significant figures. See the instruction now. Whatever you calculate here now, you have to leave your answer in 3 significant figures. Now calculate the distance, that is line PR. Where is line PR? Line PR. So you can now say line PR equals to Q. PR. Once you do like this, you continue. So let's now write our formula outside. So I need this place. So this is what I need. Q squared equals to the other two sides, which is known R squared plus P squared minus the 2 again. 2 times R times P cos what? Cos what I'm looking for, Q. You see how I'm writing it. You don't need to memorize anything. From the diagram, you just bring that out. I'm looking for this side. Then the remaining two sides is squared minus times the remaining two sides. Then cos of what we are looking for. So now let's now input their value. From here now, I'll now say Q squared equals to what is R? R is 8 meters squared plus P. P is what? 13 meters squared minus 2 times 8 times 13 cos. Okay, we have to stop. We have not analyzed our angle. So if here is 50, look at it, very simple. Here is alternate to this, like you are changing the face. That is alternate. Here, from here is like this, but at the other end is open. Here is closed, at the other end is open. You call it alternate. But if it's closed here and with the same line is closed, you call it corresponding angle. Because it does not change, it's still at the same position as the initial one. But once it's closed here and at the end is open, you call it alternate angle. Here now, close, open. Close here and open here, alternate. And the same line. If you now have it here on the same line, call it corresponding angle. So which means here now is 50. If here is 50, how will I now get this place to make this thing complete? Very simple. We know that from here to this place is 180. And we already know from the beginning to half of it. So the remaining one rather now, which is 180 minus 150. You have this place as 30. So the total will give you what? 30, that is 80. Is that clear? Let me bring it out. I have something like this. But you see now, I have here as 50. So alternate here as 50. And I have a line that moves like this. I need to complete this way to know the whole stuff. Now, and we know that an angle that moves from this line to this other line, straight line, angle in straight line, is not 180. So if here is 0, here is 180. Now, and I already know from here to here is 180. So what will I do? And I know from here to here to be 150. So if I now go remove 150 from here, won't I get what is here? And if I remove 150 from 180, here is 30. So for me, if here is 30, for me to now know the total angle, 50 plus 30, I already have 180. That's how you play with the quadrant. Just be manipulating anyhow. You are the owner. Control it. You are the owner. So now, here will now be cos what? Cos 80. So I'm going to point this. Q square will now be equal to 64 plus 19. I think it's 169 minus. You have to use my calculator now. 13 square. Okay, 169 plus 64. I have 223 minus. So it will now be 2 times 8 times 13 times cos 80. That gives me 36 minus 30 minus 36.12 minus 36.12. So we subtract it. So 233 minus 36.12 equals to, so we now have q square equals to 196.88. So we now find the square root of both sides. Square root of 196.88. That will give us square root of answer. Square root of answer. So you have 14.031 like that. Now don't forget the question says put your answer in what? 3 significant figure. If I should write 14.0, this is not a 3 significant figure. This is 2 significant figure, because this 0 does not count until a number is behind. Until a number is behind, that is when this one counts. Because this one is 0 and this is 2 significant figure, and I'm to leave it at 3 significant figure. So I will now pick one number, join it. So this 0 now has meaning. After a point, and you're having, if you have 1,000 zeros, it does not has meaning. But if you now add 1 behind the thousands, after 1,000 zeros you add 1, then all those zeros become meaning. So in 3SF, you write this one, write the unit meter to 3SF. So this is your final answer. Now, I hope you get it. If you are not too clear, you watch the video over and over again. So we have it as a 40.03. Q to be 14.03 meter. So now, any other question? Question say the bearing of P by now. I hope you should know how to manipulate now. The bearing of R from P. Bearing of R. Bearing of R from P. We need to calculate the bearing from here to this place. Don't forget everything starts from north, which is 0. Now, how do we now calculate bearing from here? We need this place. Once I know this place, I will just add it to this place. You see, you can manipulate yourself. You can manipulate it. This triangle is easier to manipulate. See something. Something move like this. So, and I have something like this. Okay, and I said I should calculate the bearing of R from P, which means I need to calculate the bearing of R from P. So I need to calculate from here to this point. How do I know that? I already know from here to here as 50. So I need to calculate this point so that I can now add it to this place. Then I find my answer. So now since I know this one, I know this side, I can use sine rule. I can also use cosine rule, because I have all the side and I have one angle. So I can then I have not gotten this one, I cannot use sine rule. Now that I have known all the side with one angle, I can now use sine rule. So why would I use sine rule? Because sine rule make my work faster. If I should use cosine rule, get the same thing. Because cosine rule is longer, you have to be substituting. You now put what is this angle here. You now collect time. By then you doing that, I already use sine rule and I'm out of the place. So what is sine rule saying? Let's write our formula, sine rule formula, in what we have on the board. So I will say sine. I will say sine P over small p equals to sine q over small q equals to sine r over small r. What do I need? I need to calculate angle P, which is our first thing. I need to put this one. Let's see the any completed one. So the completed one here now is Q. Because we don't know this angle, this is another unknown. You know half of it, you know the side, you don't know the angle. If you are to use this and this, it becomes two on. If I have to use this and this, it becomes two unknown. So I can use this and this, or this and this. Because the point I'm going is to calculate P. So let me just use this angle here. Let me just use P. Okay, which one is completed? Okay, this one. This one is completed one. So this one is half completed, half completed. So which means I can use either this or this, either this or this or this or this. Now I have to use this or this because my focal point is what? Is to calculate this angle, which includes P. So I'm using this and this. So let's substitute at the value. Sine P unknown, small p 13 equals to sine q 80, sine 80 over small q. That is what we just calculated, 14.03. So to make P the subject of formula, this time this divided by this. So sine P will just be 13 sine 80 divided by 14.03. So sine P will be equal to, using my calculator, so I have 13 sine 80 equals to divided by 14.03. So what do I have? I have 0.9125. So P, so because I'm taking this sign to the other side, that is anti-sign, but we'll call it arc sign 0.9125. So therefore P equals to, I will press shift on my calculator, sine, then put the number 0.9125 equals to, that is 65.9 degrees. Now since I've already calculated it to be 69.5, I am applying this way. Okay, let me use this side. 69.5. Now I've forgotten this place at 65.9. So what do I need? I just need to add 50 to this one to get the bearing. So we say therefore the bearing of R from P equals to 50 plus 65.9. That will give you 65.9 plus 50. That is 115.9 degrees. So that is the bearing. Very straightforward. Now the last one, okay, is it the last question? So now we've calculated line PR, the bearing of P from Y. Calculate shortest distance between point Q and line PR. Q, line PR. So you now go back to the diagram. This is Q here. We want to calculate the shortest distance between Q and these two lines. So the shortest distance is that the singular distance, this form elements they mention here. So you have to now draw a straight line that is going to be perpendicular to this line. You draw a line from this single alphabet to this line here, a straight line forming right angle to this line. So then from there you now continue. And the question now continues and say find the shortest distance, hence you find the area. So we now need to now find, you join a line from the point Q to the two other lines. From this line, draw a line here, of which here will be 90, here also will be 90. So are you getting it now? So now we already joined a line from here now. Then you see that we can now calculate the shortest distance. We have to calculate the distance. Let's just call it y. Distance from here, say line. If you let's call this place m. Line q m. Let it be y. So I can now, anywhere you see y, know is the shortest distance from here to here. So you get the how to interpret it. Anytime you are asked the shortest distance, you see those things they are asking you is to join a perpendicular line from a point, from that single point to the line they are referring to. You draw a perpendicular line from that point to the line. So which is this? So we just need to calculate this is the shortest distance between here and here. If I should take this route and moves like this, by the time I add 8 plus 13, that will give me a longer distance. You see now, that will give me a longer distance. So the only way to move the distance between here and here is to not divide this, bring it a perpendicular line, then you find the height. So now from here now, finding this height is very simple, right? Because we already know this angle. Don't forget we know this angle. What did we even get the other time? 69 point. We got it at 69 point. This angle P here. This angle P here. Let me call it Q. Let me call it angle angle QP, angle QP, QPR, angle QPR. Yes, QP. We've gotten this one the other time at 65.9 degrees. So I can now say opposite hypotenuse because the right angle. This PQM is a right angle triangle. So sine opposite from SOHCAHTOA. SOHCAHTOA. So which one will relate here? Opposite hypotenuse, sine. So I will sine P equals to opposite y over hypotenuse r. So my y equals to r sine P, which is equal to r is what? 8 meter, sine my P 65.9. So y equals to 8 sine 65.9. 8 sine 65.9 equals to, that is 7.3. So 7.302. 7.302. So we are having that. Then meter. So we are having this. So we now have okay, that is the shortest distance. So we have to find the shortest distance between what? The shortest distance between PQ, and hence area of PQ. We have to find the area of PQ. This. So to find area, don't forget area is half area of PQR will be equal to half AB. So we have the base, this. Okay, you can do it like that. It's half AB sine. I'll use it as okay. Let's use this. We can solve it actually two ways. We can solve it as this. We can also solve it as half AB sine theta. So in this case, we have to So in this case, if you are to use this will become sine, this one will become the two side. This side is 8 meter and 30 meter, then this angle between them, that is what we use here. But in this case, it will become the height and the base. This is the base angle and this is height of the angle. So I'm using this one. So that will become half, that is the area of a triangle, half height times base. So 1/2 times the height, which is what we just got. What do we get? 7.3. 7.30. 002 something. Then the base here, 14. That is 14 point times 14.03. 40.03. So that's what we have. So 40.03. So let's multiply our answer. We have 7.302 multiplied by 14.03 equals to divided by 2. So this will be the area 51.2. So 3SF 2, 2, 3, then 1.2, 51.2. What's the meter square? The unit of area is meter square. So that is how to answer. This one. So don't forget, in bearing, they said, they asked us that they didn't even ask you the shortest distance, say find the area. So it is now left for you to first of all calculate the height. Once you know the height, so which is just the shortest distance between Q and line, this line, then we have this. So, and we have to find the area of PQR. So if you have to find it, we already know the height, and this is the base length. This is the base length of this angle. So if here is the base length, you have 1/2 the height, which is y, multiplied by the base length, or say the half. When you are using sine, sine means these two AB you are seeing is now the two side and the angle between them. So half this times this divided by 2 times this angle. That is how to solve it. So that is all about bearing. Don't forget, I said you need to manipulate your way with the quadrant. So don't forget, this is the quadrant. This is 0, 90, 180, 270, 360, and all angles start from here and it moves. So thank you. God bless.